Well, yeah, sure. I mean, it's, a bunch of people are getting mad. I think the question is, how long is it going to stay this way? And nobody knows.
I don't think China will back down because this.
No,
China,
not.
like, China won't do anything that other country won't do. I mean,
yes.
Just, in a way, China just want to have equal treatment.
Well, no, I don't think so. I mean, China wants to steal intellectual property, and they made that very clear, and they totally do.
They have to,
Well, that's their argument, but it is understandable that the U.S. doesn't like that.
Well, China will threaten. The U.S. military is patrolling the border, so China will threaten. So they have to get new technologies. So like
Well, anyway, I mean, there are real issues, but it doesn't look like there's going to be any solution anytime soon. Yeah. Anyway, I found a few news articles that are pretty interesting. This one here may be the most important of all. Apple got sued over the Apple App Store with antitrust lawsuits, and the Supreme Court approved this to go through, which is a mighty strange thing to do when Apple only has 45% of the market. That's not a monopoly. And yet, of course, this isn't a final ruling that they're guilty, but this is going back to the court, and they've already won once and then lost once in lower court. But people want to, Apple forces everybody to use their app store, and they charge 30% of the price. And they're trying to declare that something is illegal about that. And it's not really clear what is illegal about that because they're not a monopoly. They should be allowed to charge anything they want. But anyway, we will see. Google Play does have an option to charge money, but almost nobody does. So I don't know. I don't know if Google takes a cut of it. But they certainly don't force you to use Google Play. You can just put your app anywhere.
No, I mean Google does. Google charge money for using it.
No, they don't. You can put your app in Google Play for free. And Apple, I don't think you have to pay to put your thing in Apple Store either. And you can put free apps there. But if you do charge money, they take 30%.
I mean, that's the same thing as Google is doing anyway.
It could very well be, but of course, Google doesn't force you to use the App Store. It's an interesting issue. Of course, this is one of the many issues coming up now. The tech companies have created new business issues, and the law is chasing around behind, trying to decide if there's something wrong with this or not. And I think the law always anyway. Yeah, and I think the real lesson came down here. This is the thing, I think. Washington is in bad mood towards tech. Their feeling is tech has to be accountable. Now, I think probably the best analysis of this is what Bill Gates said after the antitrust lawsuit over Windows 98. He said the problem is we weren't paying our bribes. You have to paying our bribes. He didn't say it that way. What he said is you must donate to political campaigns. If you don't donate,
what Google is doing now is people are cracking up the lobbying fees now.
Well, if you have to donate to political campaigns, or the politicians have nobody on your side. Basically, you have to bribe someone, and if you don't, you're a victim. That's right. That's right. So I think, that's my opinion. Some people think I'm too cynical, but I don't think it's possible to be too cynical about government. Anyway, so we will see what comes of this. In any case, it's going to be snarled up in the court for the next couple of years, even if Google is ultimately fined or forced to change their business practices. There's a game that Ming Chow pointed out to me. This is a cute cross-site scripting game, which I think came from Google, and it's very nice. You have 6 levels of cross-site scripting, so it's a fun little game. It should be a project in this class. I think it's too late to edit this semester, but I went through the first few levels. This is good. You have to use. You have to perform cross-site scripting on a series of levels.
Is that the same thing that you do in your cosine?
Yeah, but it's a little bit prettier than mine. Yeah, very similar to my projects, but it's nicer. And
how did they make it into the game?
Oh, you have to start it, and then you get to the next level. You have to cross-site script here. So this was you got hints, and you got a target here, and you have to find some way to. Well, I'm already on level 3, but there's some way to get back to level 1. Anyway, because it remembers I already done it on this machine. But if
Is it more like a competition kind of thing?
No, you just have levels to get through, and there's hints and stuff. But next semester, I'll probably just make it so it's worth some points, and you can turn in a screenshot, see how far you got. But it's good practice for cross-site scripting. So Human Rights Watch got the app. apparently in this district of China where the Muslims live, they really strongly surveil them, and they say they took 1 million of them and locked them up. And
I think that's true anyway. Because when you visit China, all those Muslims, they are moving all over China to do business. You know, they have free access to everywhere.
yeah, well, I really don't know. Anyway, they're doing the same thing I think they do in Israel. They're just using blatant profiling to track down people, like if you are related to someone who committed an attack, or if you change your participation in government services or something. These are the things that make you suspicious. So anyway, Human Rights Watch is upset about it. I'm not.
Checking personal information.
Yeah, yeah.
But isn't China is doing more like an experiment to keep the citizen like
Yes, yes, that's exactly.
More like Nazis.
Yes,
Kind of thing, right?
that's right, and that's what they say. And they say what they do is they're testing out their extreme surveillance on a small, unpopular minority who can't complain, and then they're going to roll it out to all of China. And I think they've already got it to where you have like a social quality score.
Yeah,
and
it's not a small area; it's a big city. It's one
yeah,
of the big cities.
Yeah, that's right. Yeah. Anyway, so we'll see what comes of that. I know China has a lot of blatant social engineering. They always have. I mean, they don't have the concept of like. They have a very different concept of freedom than Americans. They accept a lot more government meddling in your life.
No, they copy a lot of Germans.
Yeah, yeah. And so do we now. Ever since 9/11, we're copying a lot of German stuff here. A lot of the Republican rhetoric is all from the Nazis.
If you look at the technology, they copy a lot of stuff from Germans.
Yeah, yeah. Anyway, and we're copying from them now. We're going to have the Great Firewall of America and block all this political stuff on the internet. We're headed the same way. Anybody.
Yeah, you don't want political interference in the election.
That's right. That's right. Anyway, so this is another supply chain attack. This one is a keystroke logger, and they put it in the HackerSafe logo. So the company that makes one of these HackerSafe tests got hacked, and they put a keylogger in the logo. So that's good, clean fun. And here's another one like it, I think here, yeah. So the hacker group compromised this thing called Alpaca Forms and Pick Real, and they managed to infect 4,600 sites. So this is, every week there's another supply chain attack. This is the big issue. If you include widgets or JavaScript libraries or any kind of code that comes from somebody else, then they can change the code on your site. And whatever code they added to their thing can change the code on your site. So these supply chain attacks are the new hotness.
So these companies with libraries for the website?
Yeah, yeah. They used somebody else's library, and if somebody changes that, then it appears another appears on your site. Another version that's been going on for at least 10 years is malicious ads. You buy an ad, and the ad actually loads from somebody else's server, so you can put malware in the ad. You just, it's it would be nice if your code was all from your server and it was all code you put there, but the modern world is far more complicated. Yeah, that's right. So Google I/O. Google is adding some new features to protect you from browser attacks, which I thought are pretty good. So they've added a cookie parameters. You can say whether you have a same site or a cross-site cookie. So you can make a same site cookie. So it can only load to the same page and cannot be stolen by the other page. And that sounds good. Now, another issue is if you're to use a new feature like that, how do you know if the user's browser is actually enforcing that feature? And now they have a thing called fetch metadata request headers. So you can ask the browser whether it's really doing that, which is pretty cool. So that's a new solution to a big problem. People are using old browsers. So anyway, this is pretty amusing. These guys advertised an unhackable flash drive. If anybody ever tells you anything's unhackable, you don't want to have anything to do with them. They're obviously idiots. Nothing is unhackable, just like nothing is perfectly safe. Nothing is perfectly bug-free. These are stupid things to claim. Nothing is that good. And it is. And so what they found was that this so-called unhackable USB drive that's encrypted made the same mistake as the first generation of USB hard drives, which is they have an app and you have to put your password or thumbprint or something into the app. Then the app sends a password to the drive and the password never changes. So it doesn't actually encrypt with a unique key on the drive. It just sends a password. And all you have to do is run Wireshark and snip the USB and you can find the key, and now you have the magic key to get in all the drives. The same thing happened to a whole bunch of hard drives This is just ridiculous. But you know, it's anybody that tells you their stuff is unhackable are just advertising the fact that they don't have any actual security staff. What they've got is a bunch of idiots pretending to do security. Because if they had any professional security people, they would never say it was perfect. They'd never say it's unhackable, because those are stupid things to say. They would say something more careful, like uses AES encryption, you know, or something like that. Anyway, so here's HackerOne. This is a pretty good report from HackerOne. These guys, they found a vulnerability that leaks out Twitter protected tweets. So you can do this. I don't know why you would, but a lot of people do. You join Twitter and then you hide yourself so people can't see you. And you suppose that only your friends can see it. This guy found, right in the spirit of this class, that what you can do is you can do a query to see if certain words are in that tweet, and the response is different if those words are in the tweet than if they aren't. So you can now ask yes or no questions, and he found a way to use ORs here, so he can ask up to 50 questions, and the end result is whether the combination is true or false. So you can do like blind SQL injection, you can do blind queries, and you can guess what's in that protected tweet and leak out information from it. So it's pretty clever. And it's very much like SQL injection, and he got some payment from Twitter for that. So anyone else experiencing some weird lag in the video screen? My screen share is 10 minutes behind the audio. I don't know, that's rude. It may be because I'm using a VPN. I can turn that off and see if it makes any difference. All right, thank you for telling me. I don't have a way to check your user experience at the other end. Let me change. I am using a different networking system because it was always complaining about my networking. Let me change something here and let's see if that makes it better. So there may be some degree of interruption while it switches to a different network. Now I'm just going out danger zone with no VPN, which was slower in my test, but it should be simpler. Okay, good. Let me know, guys, what you see out there. Same here. Okay, good. Well, I have now changed to a different network. So last time you restarted the video share. Okay, I'll stop the video share and restart. That's harmless enough. Stop the share, restart it. Okay. Probably a good idea since I changed the network. All right, so let's see if that makes it any better. Now I have, that fixed good. Thank you for telling me. Okay, so anyway, another chat message is coming in. Looks great, good, okay, thank you for telling me. I need the feedback because I don't have any way to know whether you people are seeing anything good out there. Okay, good. All right, so I think we're done with the news. Let me see if I can get this stuff off my screen and let's carry on. So this is the last class. And we're here. So this is the end of 129S. And the last class for the whole semester is in 2 days. Wednesday evening class is the last class. So I have Monday, Tuesday, Wednesday classes this week, and that's it. And then we have the final exam starts on Wednesday and until next Wednesday. It's online. You have one chance to take it. It's an hour to take it. And all extra credit is due today. You can still turn it in until the final exam, but you'll lose some points for being late. And all right. So let's take a look at some of these ways to attack other users. And this makes more sense to me than last time. Last time I couldn't make much sense of it myself. This time it's more familiar stuff. All right, so client-side injection. This one is like HTTP response splitting. And I learned this from a WebGoat product, which is an OWASP training product. I remember years ago I went through it. It was very nice. This is a cute trick. So suppose you take a parameter from the user and then you put it in the page. So here, there's a parameter called language equals English. And so if I send a GET request with that parameter in it, it's putting a cookie at the other end. So this looks like an opportunity for cross-site scripting, if you want to look at it that way. There's a parameter that came from me, which the server then echoes back. Now, all right, you can inject things in there, saying like location and set cookie. So if that happens, if I can inject carriage return line feed, then I can change the English to English carriage return line feed foo:\bar. And now I will have a set cookie and I will add a new header line here because carriage return line feed is what separates header fields in the HTTP response. So now I can change the header of the HTTP response And if therefore, if I'm having trouble putting in these encoded carriage return and line feeds, there are ways to encode them, like double them or doubly HTTP encode them or put a null byte before them. You know, the usual tricks we've used many times before. But if you find you can somehow inject them, then what you do is put in a carriage return line feed. Now you can set a cookie and determine the session ID. So now the server thinks it's telling me my English language, but it's actually setting a cookie on the person who's viewing this. So I can now put cookies on other people's machines that appear to come from that site. And this in itself might not be too bad, but if I have a session fixation vulnerability we'll talk about later, that can be enough to get me in their account.
Is the host location?
Does what?
Is the host location?
Is the host location. The host tells. Host just determines what the URL you're trying to go to, what the name of the server is.
You say you can inject cookie and location.
Oh, just that's typically what you'd have here. It seems like language and location are typically what you're putting in. That's all. It could be anything, but those are common parameters that are used in this way. So now I can add an extra header line and set a cookie, and therefore I can deliver an entire page. I can put in an entire virtual page in the response. So here I can insert, here I'm going to insert, I have a chance to set the author, and in here I'm going to put in a carriage return and a content length, and then malicious content up to that content length, and the real content is down here and it will be ignored. So I set this up so you can see it. It's header.htm. So let me bring it up here. All right. So here is a page that asks me what language, and if I say English, it says hello English speaker, and putting it in the header. But if I put in this mess here, here's one that will just post the line pwned. So it's going to put in English and then carriage return line feed content length 28, and then carriage return line feed, carriage return line feed, and then a 28 character web page, which prints out the word pwned, and then complete it with HTTP 200 OK. So it's going to put another request down there that will be ignored. So now I see a web page here, which did not come from the server. It's entirely up here. So you can make a URL that will show a completely different page. So it could show something like a login page that collects their data and sends it somewhere, or anything I want it to say. And this is in the general category of cross-site scripting. I've taken something and bounced it off somebody else's server, so it appears to come from their server, but it wasn't really hosted on their server. And here's another one that puts here's an example of how to put a form up there with a longer page. Now I can put up a whole page here that now has a picture and asks you to put in confidential data, and all that page is up here in the URL. The real page is not showing at all. Yeah?
So with the code that you just put in there, is it possible to actually put it in even a short, like Bitly?
Yeah.
And I can make it even.
Yes, and that's what people often do is put it in Bitly or tiny URL, exactly. Yeah. All right, so that's the kind of thing, and almost all cross-site scripting works that same way. You have some parameter you control which can bounce off the server and then run script on somebody else's machine or have some unexpected effect. And you can even poison a cache. A lot of websites are cached. Mine is cached at Cloudflare. Usually your company has a cache, your browser has a cache, servers all over the place have caches. So you can send a request that has a split response and you can put poison in the cache. So the fake page is in the cache, so now all the other people that went to the real URL will see the fake page because it's cached in an intermediate stage. So you can do a lot of harm that way. All right, so of course, if you want to prevent this, you shouldn't be using user-controlled input. If you have to, then filter out special characters. But that's the answer for pretty much everything in this whole course. All right, you can inject a whole cookie. Now, modifying a cookie is perhaps not too bad an attack. It depends on whether there are other vulnerabilities. But if I inject a cookie, then I can do it perhaps from another domain. It might affect the main domain, or I can send a malicious cookie easily with a man-in-the-middle attack if it's not an HTTPS session. And that's another way to do it. So some Now, why would injecting a cookie matter? Because the cookies that matter should all be set by the server, but there might be some cookies like use HTTPS equal false that I can set, which will change the behavior of the page. And there might be pages that trust cookies because the website is just disorganized. So if I set a cookie on one page and the user goes to another page, it might assume that that cookie came from the server when it didn't. So that's the game here. All right. And so you can use cross-site request forgery to trick the user into loading the script. That's one. And then there's session fixation vulnerabilities, which I think is what, yeah. So this is the point. If you come to the server and the server tries to decide if you have already logged in, sometimes it just says, do you have an authentication cookie? If you do, you must have already logged in. It doesn't actually keep track of whether you really passed through the login process, or when you log in, it lets you log in, but it continues to use the same token you had before. So this is session fixation. Here's how it works. The attacker goes to the web page and logs in. Now they have a cookie that they control. Now they send that session token over here. Now the user logs in and it reuses the same session token. Now you're using a session token that the attacker has, so they can now break into your session. And this is because you came to log in and the application used the existing token instead of always giving you a new one. It's kind of surprising to me that anybody would write code that way, but apparently this does happen. I've never seen it, but it certainly could happen. So you inject the token, and then you can sometimes put it up here in the parameter in the URL or other ways, like these other vulnerabilities. You have a way to put that token. So here's one, you can do it without login. They put items in a shopping cart and you check out. Then you review data. I can now fix an anonymous token in your browser and go to this confirm order page to steal the data. Anyway, it's various tricks here. So if the app accepts a token that comes from the user, that's a vulnerability. Your app should just always assign a token whenever you authenticate and not believe anything that came from the user. That's the fundamental error in the whole course, is believing something that came from the user. You should not, but it's very easy to lose track of where things are coming from in complicated websites. So that's the issue. All right. So that'll be down here. Yeah, there's just every time they come in, don't accept the token, assign a new token every time someone authenticates. And it's a good idea, as we said before, to have per page tokens like hidden fields, so you know they came from your page and they didn't appear partway through some process with a token that came from some suspect place. Then there's open redirects. This is a very common vulnerability where you have a page and the page redirects to another site. And the site can be controlled, so I can make it go to a different site. So now this is used by amateurs for rickrolling and stunts. The professionals typically just use similar looking domains or something for phishing attacks. They don't really use this that much, but it is an option. So if you have a 302 redirect, it's going to go to another page. Some people use the HTTP refresh header up here. And so if I have the ability to control these parameters, I can make it go to a different page. And so here's the HTTP meta tag that does this. And here's JavaScript. You can use document location equals something that will point to another page. So if I can inject JavaScript or I can inject a header line, I can do this. And so most redirects are not user controllable, but one place they often are is return to original page, where it remembers where you were, sort of after a timeout and relog in. So when something times out and then tries to go back, you may find that that is under your control. And that was true of Hackathon. If you go to the Hackathon login page, there's a return URL, which is I think where it goes after you're done logging in. And that's just right up here in the browser bar. So you can change it to Google, and then when you log in, it will go over to Google. And the point of this is now I can make a URL which your browser will interpret as part of this site, but it actually goes somewhere else. So I can exploit the trust you might have in one domain to go to another domain.
When you exit, then you go to the other side?
Yeah, when it's done with this one, it'll go to the other side. That's right. And you'll see it right up here or elsewhere. There's a parameter. Maybe, I think it's when you log out, maybe. Yeah. When you log in or log out, it'll do this. Yeah.
So how do they keep track of? Do the website keep track of where you go afterwards?
It should keep track of where you go afterward, but a sloppily written website like this will just put the parameter up there. And it's a place where you can change it. The correct thing to do is that the next location it goes to should not be controlled by the user. It should be controlled by the server. But sometimes they put it in a place where the user can see it and change it. It's a fairly common mistake too. This is one of the more common vulnerabilities on websites. So if you want to prevent this, there are ways to do it where there's a URL and you try to make sure it's on your website. So you try to block absolute URLs, try to add a prefix. So you might block strings that start with HTTP://, but you can use the usual tricks, a null byte, capital letters, skip the HTTP, encode it in various ways, use the wrong kind of backslash, use too many backslashes, and all these things will probably be accepted by the browser, but they might not be caught in the filter. The usual trick occurs. And some people remove the HTTP://, so you can put in two of them, or put in one in the middle of another, or duplicate the entire thing twice so enough of it survives. They might try to make sure that it starts with or contains an absolute URL with its domain name. This is one that affected a lot of people a long time ago. If I want to go to mdsec.net, I can, and they're always starting with this, I can just put a dot, mdattacker.net, and now their domain name is no longer the domain, it's a subdomain of mine. So by being able to inject a dot, I've caused this not to be the domain name. That's the domain name. Another thing that people did a lot years ago is they would put an @ in. So you would make a URL on a phishing site that said microsoft.com@evil.com. And your browser would only be a certain width, so you'd see microsoft.com. But it was not actually a domain, it was a username at another website. And that's the same as this. mdsec.net is not the domain, it's just the subdomain of this domain. It's a common trick. All right, and some websites automatically add, so the only part I control is updates here, and it's actually going to add this part, hard-coded, mdsec.net/. Now that's a pretty good solution. That means that everything is going to have to be on their server and not mine. But if they don't remember to put the slash at the end, if they actually always prefix it with this, then I'm not going to be able to change the server no matter what I put in. But if they forget the slash, then I can, of course, just do this with a dot, like I was saying. All right. So, of course, the usual answer, don't put user-controlled data in there, or if you do, just have the user choose from a list of sites and only take canned sites. You don't actually take characters that came from the user and put them directly in something that's important. Anyway, all right. So here's the plan, use relative URLs, prepend everything with the domain, including the slash and so on, or just verify before using it that the domain is really going to your domain. Those are all good practices. There's also HTML5. I've never seen this. I don't know how to use it. HTML5 now has the ability to store databases in the browser on the client side, which would seem like an enhancement to cookies if you want to store a lot of data. But then you can have SQL injection in the browser on the client side, which is kind of nuts. But anyway, it is an option. This is getting a little esoteric. Of course, I would say, what is the point? Because the client should have access to all the data on the client side. But anyway, there's probably some esoteric situation in which you can do something like steal the stored data from another site. Anyway, I haven't heard of this happening very much. But in principle, it's an option. Now, here's one I have seen, parameter pollution. And I think it's in your projects in various places. So you can, you've got a lot of parameters here that came from the user, like a folder equals inbox, order equals down, size equals 20, and so on. And you can put in two values of the parameter. So here I put in inbox with this parameter, action equals delete. And now when someone hits the reply link, it will have that extra information in it, action equals delete. What you can do, the action should be down here in the parameter, but I inject it up here in the URL. You can put a parameter in two places, both in a cookie and in the URL. And when you do that, sometimes one will take precedence and sometimes the other. So you can often add a parameter in a place where it is not supposed to be, and it'll still take effect on the server. So they call that parameter pollution. All right. So I got some cahoots in one of these tabs, and there they are. All right. And I should have a place to put them, and it looks like I do. All right. So I just got a call today. It looks like I'm going to be teaching a class in Jordan. So I went and looked it up. And Jordan apparently is on good terms with us, which is what I thought. They're in the same list as China and Saudi Arabia. They're in the good list where you can totally do things over there. Not China, Japan and Saudi Arabia. China and Russia are on the bad list, and I can't teach my crypto class there. It would be a violation of US export restrictions. But I can teach anything in Jordan, so that'll be fine. We'll work it out. They wanted me to go in July. I think I'm too busy in July, but we'll work it out. It's, yeah. Well, that's what I thought. Nothing I teach is actually new, but you know, it's just like the current trade war. It's just punishment. Naughty, naughty China, bad China. So, you know. I think I am using international standards. I'm using like RSA and SHA-1. I think those are. Yeah, but I don't know if that would, it's an interesting issue. I could try that kind of stuff, but I haven't pushed it, especially in the modern climate. I don't want to push it. Yeah, maybe so. Anyway, I just didn't do it. DEF CON didn't want it. You know, DEF CON is new in China. They didn't want to like get in trouble with the US military and the government. So they said, you better not do it. So anyway. Oh yeah, Iran, I said I wouldn't go to Iran. Yeah. We're in really bad shape. Iran is in the category even worse than China right now. Yeah, I don't think they'd let me teach in Iran. Yeah. I don't really want to get killed, you know. All right, so what technique uses the same cookie before and after authentication? Yeah, that's session fixation, where it takes a cookie before I logged in and keeps using the same cookie, which is obviously a pretty unsanitary thing to do. All right, so which one replaces the entire page? That's response splitting. I remember when I first did this, I had a lot of trouble understanding, but now it's more clear. All right, which attack is generally a prank, not really serious crime? Open redirects. All right. And which one can poison a proxy server? So many people see the altered page. That's the response splitting. That response splitting can be cached, and then people will see the page even when you didn't directly attack them. So that's good, clean fun. So Caitlin and Mateo and WITB, and I remember who WITB is. All right, good. So, and Mateo, I can spell it a little better. All right, so let's go back to the slides. We'll talk about local attacks. So if you consider the attack where the attacker has access to your machine, which is someone who's stolen a phone or a laptop most commonly, or someone in a shared environment like this, then you've got the stored cookies on the machine, especially in mobile devices. Almost every website now puts in a cookie when you log in, and that cookie is just good forever. So if I can steal a cookie, I'm in your account and there's nothing you can do about it. Another issue is the cached web content. Websites cache the images and the background and the scripts and all sorts of things on pages. So when you go back to the same page again later, they don't have to reload it. So that's in there. Now you can put in tags to tell the browser not to cache things. And I don't think I'll go through this one, but you can see it. It doesn't cache HTTPS resources, which is a good thing. It assumes anything that came in over HTTPS is probably private, and that's almost everything these days. So you'll see here, if you go to some site and search for Propecia, you'll see a whole bunch of stuff in the cache about it. 14 entries about Propecia are stored in the cache because I loaded that from Dogpile, which at this time was an HTTP site. And HTTP resources are considered not private and just cached for speed. but HTTPS resources are not. So if you just go to HTTPS and search for cocaine on Google, you'll find that there's almost nothing in the cache. There was only one thing there and it wasn't very interesting. So your browser does attempt not to cache HTTPS resources. And this is part of the general belief, which was a big deal until Google proved it wrong. A lot of people believed for years that HTTPS would really slow everything down. And you better had to use HTTP wherever you could. And Google's the first company that went to 100% HTTPS, and they said it only cost them 1% more server time. People thought that would be a much higher number. And this is one of the many reasons, because everyone's going to keep reloading everything every time it's not stored in the cache. But the net result is it doesn't really matter with modern machines. All right, then there's browsing history. We talked about this before. Your history stores URLs you've been to. So if there's parameters in the URL, they're going to be stored in there. Autocomplete is on your machine, storing passwords and credit card numbers and everything. Now, the autocomplete is a famous vulnerability. If you actually use your browser to remember things, earlier versions of Internet Explorer were attacked a lot. You'd steal those passwords. Microsoft kept upgrading and upgrading and upgrading the security of the stored passwords. Now they're stored with AES encryption in the registry. Firefox stores it in the file system. By the way, Firefox by default does not protect your stored passwords with a master password. So the next user can just go to Firefox and see your passwords in plain text, unless you turn on that optional feature. Anyway, they don't have a master password. So anybody that opens Firefox can just go and see the passwords. They're stored in plain text too. So it's an issue. Anyway, sometimes you can use cross-site scripting to trick a browser into filling things in. So, you know, the storing passwords in a browser is a fairly dangerous activity. I think it's safer to use a password manager like LastPass. That's what I use. I only store things in the browser that are of no importance. I also use multiple browsers because frequently I've updated a site, and I've found in my practice that browser caches are very hard to stop. It's very hard to really see the latest version of the page. So I just have to have 2 or 3 different browsers, which is a simple way to have different things going on. Anyway, another thing is browser private pages. That often helps. Then there's these local stored objects. This is probably most relevant in the context of Google. As I talked about, I think in the first class, Google is the most vigorous about invading your privacy and tracking. They are the most extreme. They know everything that everybody is doing. They don't just put cookies on your machine. They don't just remember your IP address. They put dozens of marks on your machine all over the place. So if you open a private browser, you delete your cookies, Google still knows who you are. It is almost impossible to stop Google from knowing who you are. And one of the things they use is flash cookies, although I don't think flash is that common anymore. When flash was there, flash cookies were the first indelible mark, where you'd store some mark on the machine and people wouldn't find it to delete it. But there's many other on there. And if you want to actually make Google forget who you are, there's a product called GZapper that supposedly does that, but I don't know how good it is, because Google has the smartest people in the world working really hard to make sure and put marks you can't erase, like your IP address, for example. So I think Google always knows what you're doing, pretty much no matter what you do to stop. Anyway, Internet Explorer has a data storage position. Edge stores local data even in private browsing. Some people are mad about that. HTML5 has another bunch of storages. Like we mentioned, you can even have a database of locally stored objects. So it's not entirely clear what the privacy consequences of that might be. I haven't heard of people using it much, but if people do start using it, then they'll have arguments about whether it's stored correctly. Anyway, you should just have a cookie. If you have a persistent cookie, it should just be a random number. It should not be an encrypted form of your username or anything like that. And even remember, if it's meaningful and encrypted, then the attacker could just replay it. Now it means something. It should just be a random number, and it should have an cross-site request forgery token involved in it, like your IP addressing involved, so the same cookie cannot be used on another system. Anyway, so here's, you can prevent caching with a lot of things. Here's the ASP, here's the Java commands that tell it to send the headers to not cache things. You shouldn't use the URL for sensitive things. All sensitive fields should be in the post parameters, which are not stored in favorites. And then you can attack the browser. This is pretty cute. You can have JavaScript that captures key presses and sends it to the server. In fact, this works pretty well. I set one up, I think. Here's an old one that worked on Windows 2008, and here's one that works on the modern machine. Yep, attack keylog.htm. And I tried it, it still works. This is the latest version of Firefox, and it's still working. So that's good, clean fun. Keylog.htm. All right, so if I type secret stuff, and then as I type, it is stealing it and sending it to a server, and here's the server. And you'll see it there at the end. It got broken into 2 pieces, but you can have a JavaScript keylogger, and this is in fact what I think this is what that banner that said this site is secure had. They put a JavaScript keylogger in the secure banner by hacking the supply chain. So it's pretty nasty, and that's all the code it takes, not much at all. Just some JavaScript that gets the key presses and then sends it to this other server. So I'm at ad.sam's class, and it's sending it to attack32.sam's class, which is a totally different machine. So, it's pretty nasty. I can totally steal your data and send it somewhere else, even in a modern browser. All right, it only catches keystrokes while the frame is in focus. It's only applying to the one frame where the script is running. So it's not gonna, if you open Notepad and type in there, the JavaScript keylogger is not gonna get that. But still, that's pretty bad. And there's a reverse stroke jacking attack if you find another browser vulnerability where you can run code in a frame and catch things in the frame above it. You shouldn't be able to do that, but there are tricks to try to do that. All right, here's the one that was a big scandal years ago. If you go to a website and you click on a link and then you come back, the link turns purple. There's a different color for links you have visited than links you have not visited. So what you could do is you could make a page that has like the top 1,000 websites on it in like a tiny font, and you could then see what color they are by doing a query to the browser. So you could find out if people have been going to a page. So now you could pop a box saying, I've detected you going to this page, you better pay me to shut up or something. And so people were all upset about that. I think it's been fixed for a long time. That was a information leak vulnerability, where you could find information like that Twitter vulnerability we were talking about by guessing, and you could verify whether your guess was true. Anyway, you can also determine if people are logged into third-party applications. This is a similar vulnerability to what we've talked about before. Most websites, or many websites, have some way to tell whether you're logged in. Like when you try to open like a Facebook post, you'll either get a response of that post or you'll get a response saying you have to log in first. So you can do something here, and here this script puts up an error handler and then makes a cross-domain request. So you can request a page that can only be viewed by logged in users, and you'll either get an error or not get an error, and you can detect that on the server. So I can find out, for example, if I have an attack where I'm going to trick you into buying my book at Amazon, I'm going to see if you're currently logged into Amazon. That's the sort of thing you might want to do here. So here's an example. This one here, I inject a code where it's on error, it's going to run script, and then I have a script, and the source comes from an ASPX page. So ASPX is not JavaScript, so when it loads it, there's going to be an error because it loaded stuff that was not script, and that will create the error and run this script called fingerprint, and the fingerprint script will then check to see what it got to decide whether you were logged in or not. So you can do these arrangements. There's quite a few variations of this where you use these cross-domain requests to do things, like you can do a little bit of port scanning. I haven't heard of this really doing a lot of harm. This is getting kind of esoteric. But you can trick your browser into making requests to other sites, and you can tell whether they succeeded. So to some extent, you could do a port scan from a browser, but in fact, it's pretty limited. For example, browsers now block things like port 25, popular ports that you shouldn't be using. They'll block them. And you can't really send like a normal SYN or anything. All you can send is an HTTP request to those ports. So things that are not web servers usually won't respond to an HTTP request, although some services will respond even to an invalid request or an error message or something. So you can try doing it, but it is really pretty limited how much harm you can really do from this attack. All right. A similar one that's probably more worth worrying about is DNS rebinding, which we'll get to, which is, I think, the more modern version of that attack. You can send arbitrary binary content, but it will always start with an HTTP header. So you're only going to be able to exploit sites that will tolerate a lot of extra junk in the request, which is sometimes that case. But that one, I think, is relatively limited. But you might be able to do more if you can combine it with other browser bugs. But this is the modern hunch, DNS rebinding, because of the Internet of Things. The Internet of Things devices typically give you administrative privileges without logging in if you are on your home network, which is an enormous convenience for people. If you're at home, you can change the lights and the music and the burglar alarm and everything without having to log in. And they figure that's safe because they can tell from the network traffic whether you are at home. And the DNS rebinding attack is what prevents this. So I make a URL, I define a URL, and I make a DNS server that gives different answers on different requests. So when you first type in evil.com, it goes to the DNS server and gets the right IP address. So it goes to my server and loads the page. Then the page tries making requests with a subdomain of evil.com that sometimes resolves as 127.0.0.1. So the source of the requests is sometimes local and sometimes not. So I can sooner or later get lucky. Now, when I tried to do this several years ago, the best attack was this thing called DNS rebinding test case. You were able to do this thing. It would do hundreds of requests and take hours, and eventually it would happen to get the right resolution from the DNS server at the right time, and it would actually do an attack which succeeded. I heard from Kaz, who just got a job at NCC, that NCC Group has invented this thing called Singularity of Origin. This thing supposedly efficiently does DNS rebinding in just a few seconds. I haven't tested it yet. It would make a great project for this class. But the point is, here's how it works. You go to the web page. The web page has this tool. Then it opens this page and makes requests, and eventually one of those requests is interpreted as being local, and now you're authenticated to some local service like Jenkins as the administrator. So it sounds awesome, and I'd like to see if it actually works. The previous demonstrations were extremely clumsy and unconvincing. This one supposedly is smooth and efficient. So that might make this more practical. There are a bunch of frameworks for this. Beef is the main one I heard about. Beef has been around for several years, where if you can get in the middle, it can add JavaScript to an HTTP page, not an HTTPS page, and now you can run JavaScript in people's browsers, which sounds more powerful than it is. You had a project here where you played with Beef, and you see most of the fun stuff doesn't work. People fix them, but you could inject keystroke loggers and so on. You might be able to do some of this port scanning, browser fingerprinting stuff, but this has been largely patched and moderated, so I don't think it's as dangerous as it used to be. All right. In general, this is why nobody should be using unencrypted communications. HTTP should pretty much be dead. Everything should be HTTPS to prevent that whole range of attacks. Anyway, a lot of websites still use HTTP and HTTPS, as we discussed, because even though they can afford, like Amazon can certainly afford to use HTTPS, the problem is they have business partners who have not yet upgraded. So they can't be 100% HTTPS until all their business partners are HTTPS. So for the foreseeable future, they have to mix the two technologies. And that's the same thing with IP version 4 and IP version 6, and with old browser versions and so on. Everybody is pretty much running mixed networks that have some old stuff and some new stuff working together in order to really solve the needs of business, even though it's dangerous. So if you're a man-in-the-middle attack, you can, of course, trick any HTTP request into loading the wrong thing, and that's pretty dangerous. If you have an HTTPS only domain, there are still some attacks you can make. You can try to send a redirection from an HTTP. If they have any HTTP request that redirects to HTTPS, you can catch it before it redirects. And your ways to escalate an HTTP access to HTTPS. You might be able to set a cookie on HTTP, and it would then be used in an HTTPS request. And that sort of thing might happen. All right. And some browser extensions don't understand the difference, so you can trick them and so on. All right. But I think the barrier between HTTP and HTTPS is getting stronger all the time. All right. So we got another Kahoot somewhere, which is here. Okay. That's it. Oh. There. All right, I'll wait a few seconds, see if we got any more. All right, I guess that's it. All right. What's the persistent data you get with HTTP that you don't get with HTTPS? Okay, you don't get cached contents. All right. Which one of these is created by a browser plugin? LSOs, those are the flash cookies. So which method evades the same origin policy? That's DNS rebinding. I trick it into thinking something is local when in fact it came from a remote server. All right. So which one will allow a script in a frame to grab something from the containing frame? They call that reverse stroke jacking. All right. And which one is only possible if the target ignores extra data? Okay, that's the point. You can actually communicate with a non-HTTP server from the browser sometimes, but you're going to be sending extra junk to it. So it would have to be a relatively tolerant process to fall for that. All right, so Caitlin is in here twice, and so is Mateo, and Stan is in here once. Okay, so those are the winners, and that's it. I've run out of time to teach you any more stuff. So I'm just going to go upstairs and see if anybody wants help teaching classes or anything, or doing projects or anything. And that's it. Unless there are any questions, I see a chat message coming in. Stan. Oh, okay, good. Oh, thank you for telling me. I thought that was a real name. I'm glad you told me it isn't. Okay. Okay, I got your name. Good. And okay. I'll give it a few seconds to see if anything else comes in. Other than that, I'm just going to stop it and go upstairs for a while.
What is a MAC address?
A MAC address? Yeah, I'm going to stop this and I'll talk about it. The MAC address is a hardware address. So it is hard-coded in your physical NIC, and it's a 48-bit number that identifies that